Okay, so far we have covered um, intensity of sunlight and the direction in which the sunlight hits the earth. And now we can start doing some things that make things understandable and predictable. So before when we were talking about the earth, we learned that the reason why it's hotter at the equator than it is at the North Pole is because the equator is getting more intense light. The sun is shining on the equator. As we go further and further north, what happens is that angle of the sun decreases. So if you're on the North Pole, don't know if I can do this on the camera. We're gonna have to aim it down a little bit. Work with me, camera. There we go. So if the sun is shining on the earth like this, and you're at the North Pole, you're having to look all the way on the horizon to see the sun. If you're at Canada, you don't have to look as far, but you're still having to look at an angle. But if you're at the equator, you're getting the most intense sunlight. And this changes because we said that the Earth is tilted at a 23.5-degree angle. So on the first day of summer, our summer in the northern hemisphere, the sun is shining directly above the latitude called the Tropic of Cancer. And at 23.5 degrees south, that would be our first day of winter. That's when the Earth is tilted away from the sun. It's then at 23.5 degrees latitude south is the Tropic of Capricorn. And that is the first day of winter. First day of summer, first day of winter, the summer solstice, the winter solstice, and the first day of spring and the first day of autumn is when the sun, even though it's tilted, it's hitting the earth like this, and the sun's going to be directly above the equator, which means if we look at the circle of illumination, we're getting the same amount of daytime and nighttime. Now, most globes will actually have a little figure 8 thing on it. This one doesn't have it because, well, quite frankly, it's tiny. And what that figure 8 thing does, and that figure 8 thing is called the analemma. The analemma looks like this. You guys will get a paper that looks like that. The analemma, what the analemma does, is it allows us to figure out on what particular day the sun is directly above the earth. So where is the noonday sun? Noon is when the sun is at its highest point. What latitude on any day that's not the winter solstice, that's not the summer solstice, that's not, I'm sorry, yeah, the summer solstice, that's not the vernal or spring equinox or the autumnal or fall equinox. What if it's just some random day, like, I don't know, November 19th, which happens to be the day that I'm filming this video. So if it's November 19th, what latitude is getting the most direct sun? Well, we use this thing called the analemma. And I'm going to get this thing off of me. And this is found inside your guys' assignment right here. This is your assignment right here. This is figure 12-4, and this will help you to answer questions 32 and 30 through 34. So how do we use it? So I'm going to switch this over to this video right here that I'm looking at the document camera. The first question is going to ask you to draw on the analemma the Tropic of Cancer and the Tropic of Capricorn. Now I'm not going to be able to show you the whole page in there. I'm just going to show you what I can. So I'm going to use a red pen here. What you're looking at with the analemma is these are the days of the years. I'm going to put on my glasses so I can be able to see this. These are the days of the years, and this is where it would be on the globe. What we're looking up here on this right here, this 0 right here, that would be 0 degrees latitude. This is the equator. The first day of spring, that would be about March 21st. The first day of fall, that's going to be about September 21st, 22nd. 21st, 22nd, the reason why it's never on the same day every year is 100% has everything to do with the fact that sometimes there's a leap year. So sometimes when you have that extra day, the first day of spring, the first day of fall, summer, winter, might lie on a different day. Okay? So that's where the equator is. This line right here represents the equator. First day of spring, the first day of fall. Okay? The first day of winter, well, that's when the sun is at 23. So this is 22 degrees and this is 24. That means 23 is going to be about right here. 23.5 is going to be about right there. Remember, I said 23.5. I'm sorry, I didn't have that on the screen. There's 22. There's 24. So 23 is going to be about there. 23.5 is going to be about right there. And just draw a line straight across. I'll show you what I'm talking about here. There we go. What that's going to be, and I didn't draw a very good straight line there, what that's going to be is the first day of winter. That's when the sun is directly above the Tropic of Capricorn. That's 23.5 degrees south latitude. And if I had drawn this a little better, you'd have seen that about December 21st, 22nd, depending on whether or not it's 22nd or 23rd, depending on whether or not that's the leap year, that's going to be the winter solstice. That means that the sun is going to be directly above the equator. So let's pretend for a moment that this protractor right here is the Earth. Okay, so here's my Earth right here. And if that's my Earth, the equator is going to move from point to point. So if the sun's shining this way, on December 21st, the Earth's equator is going to be like this. The sun's going to be shining at a 90-degree angle at this line right here, the Tropic of, my on screen, that's going to be the Tropic of Capricorn. Conversely, when the Earth is tilted towards the sun, that means the sun will be shining, the equator will be like this, the sun will be shining directly on the Tropic of Cancer, which happens to be 23.5 degrees north. So about, there's 22 degrees, there's 24 degrees, 23.5 degrees north is about right there. Let's see if I can't draw a better line this time. There you go. So that's about June 21st, 22nd, somewhere in that range. 21st, 22nd. And that's the summer solstice. So that's the latitude. If you wanted to get the most direct sun on June 21st, you want to be at whatever latitude is 23.5 degrees north. But I said today, the day that I'm filming this, is November the 19th. Well, the equator, that's first day of spring, first day of fall. That's not going to be nice. That's going to be March 21st or September 21st. But now we're, like I said, we're none of those dates. So where is the sun directly above the earth? Well, it's going to be somewhere in between. And that's where this kind of comes in. If we go to, you look right here, it goes October, or September, October, and it goes down into November. And then I say today is November 19th, which is right here. That means that the latitude that we would have to be, if we wanted to get the most direct sunlight, the most intense sunlight today, we would go right here at about 19.5 degrees south latitude. Which means if you're at the equator, you literally have to look south to see the sun at its highest point. If you're even further north, if you're in the northern hemisphere, you're having to look at one of the lower angles of the year to be able to see it. That's because we're heading in the winter. And as we move closer and closer to December 21st, 22nd, what's going to happen is the sun keeps moving further and further south. The sun's going to keep getting lower and lower and lower, which means less intense sun and less daylight, because we won't be in that circle of illumination for very long. So you can go through and figure out, hey, my birthday. If you guys want to send me presents, my birthday is August 29th. If you wanted to send me on a nice little trip down to somewhere that I can get the most sun on my birthday, what latitude should you send me to? Well, here's July, August 20th, 25th, 26th, 27th, 28th, 29th. You would have to send me down to somewhere on the globe that is about 9 degrees north latitude. In this case, if you were standing on the equator, you would have to look north to see the noonday sun. So the sun's not directly above the equator, it's directly above 9 degrees north. So, where do you guys need to buy me a ticket to go to? Well, if I take a look at my globe here again, if I take a look at my globe, I can look and see the latitudes on here, and I can see now it only starts off at 10 degrees latitude, so 9 degrees can be right there. So please send tickets for me to go to Guatemala, Venezuela, Colombia, Indonesia, Malaysia. Okay, one of those places would be fine if you want Mr. Lee to get the maximum amount of sunburn possible. Now, the funny thing about that, I'm going to tell you guys a little story right here. Mr. Lee is bald. Yeah, this is perfectly bald. And I live here in the Pacific Northwest. And during the summertime, I go out and I mow the lawn. And when I mow the lawn, do I get sunburn directly on top of my head? And the answer is no, because I live in the Pacific Northwest, which means if the sun is coming this way, and I live about here, I'm having to look that direction of the sun. So if I'm standing straight up, I'm not getting sunburned on the top of my head. I'm getting sunburned at the angle in which the sun's hitting me. So, let's say I want to go mow my lawn on my birthday. So the sun, go right here, we said that the sun was going to be about 9 degrees north. So if the sunlight from the sun's coming this way, like this, all right, I'll move this up just a little bit. And if this is the Earth, that means that the sun's hitting the Earth at a 90-degree angle. This is your 90-degree angle, just perfectly like that. Is hitting the Earth at a 90-degree angle at 9 degree north latitude. All right, so that means north latitude, that goes about like this. That means the equator is going to be about right here. If you're at the equator, you're having to look at a less than 90-degree angle. If this is a 90-degree angle, you're going to be looking at it less than 90 degrees. So if I'm at the equator, it would be 90 degrees minus 9. I would be looking at the sun at an 81 degree angle. I'm having to look to the north to see 81 degree angle. If I live in Seattle, Seattle is 47 degrees north latitude. All right. So from our perspective, if we're looking up at a 90-degree angle, if we're looking straight up from the Earth, we're not seeing the sun. We're having to see the sun at this angle right here. So what angle is that? Well, if this is a 90-degree angle and the sun is 9 degrees north, we're having to look at the sun at 90 minus 47 minus 9. So that would be Let's see, do some quick calculation here. (90 minus 47), that's our change in latitude to the equator, but plus 9 actually, because it's not at the equator. I'm having to look at a 52-degree angle to the south, which means that if I was mowing the lawn on my birthday, I would get a sunburn. The worst sunburn wouldn't be on top of my head. It would be at a 52-degree angle. And boys and girls, this has happened. I've been outside a little too much on a particularly hot day, and I've got a ring of sunburn around my head at the angle in which the sun was. So we can also look and see if you were in a ship in the middle of the ocean, you could also figure out what latitude you're at by knowing what day it is and looking at the angle of the sun. And that's what you guys are doing with on those questions. Once again, this is the video to kind of sort of help you out what's going on here. If the video doesn't help you out, make sure you read the examples inside of the assignment that you're working on. And when all else fails, make sure you do all that stuff first. But when all else fails, raise your hand. Call the teacher over. We're probably working on this in class anyhow. All right, I hope that helps. Take care, guys.